Okay, this week we talk about atmospheric circulation. So let's look a little bit at a couple of them here. Really, we're just dealing with some broad circulations in a way. There's a cold front right here. We've talked about the difference between the air masses in a cold front and a warm front ahead of it. And here's the warm front. Notice temperatures in the cold air here are around in the teens, even below zero. Up in Canada, again, they're in the teens. This is below zero areas. To the south of that, temperatures are in the 30s. So when you have a warm front coming through, air is going to get warmer. Or you have a cold front coming through, air is going to get colder. They both provide lift. And lift is what causes the bad weather in the atmosphere, that causes you issues with your flights. So if you have a warm front approaching your area, there's going to be warm air coming up and over this dome of cold air. It's going to spread clouds further out. Normally, the slope on a warm front is relatively slow. So you wind up with clouds developing well out ahead of the warm front and then get higher and more precip ahead when you get close to the warm front. Also, when you get close to the warm front, there may be a lot of low clouds around. It's another characteristic of warm front. They bring a lot of low clouds with them, so you wind up having a lot of IFR conditions. Cold fronts, on the other hand, tend to be very steep. Remember, density is very high in the cold air. So what you wind up with is a very steep air mass pushing the warm air away so that your clouds may not go very far into the cold air. They may be fairly close to the front. But because it's so steep, it may push the air up faster. It may cause you to have more thunderstorm potential and maybe heavier precipitation. Now, along this monster front here, we have a very strong low that's up over New England, almost into Canada right now. If you walk back, say we went back 12 hours, same low here over the Midwest, Kentucky, Ohio area, moving through. So you can see this low went from 999 millibars there to the latest. It's down into it's 988 millibars. So it dropped 11 millibars as it was moving north. Very strong pressure gradient, lots of wind. So if you wanted to look currently at issues that are going on with this, just looking at sigments and air mets, we can see there's a lot of turbulence along the low track. There's some icing also along it. Convection offshore, out ahead of the front, out of the head of that cold front that we were talking about. Convection develops typically out ahead of the warm cold fronts. So with that, I want to look at one thing here out for air. Here's a 300 millibar. Here's a jet streak. This, if you were flying, if you had to go from New York City out towards Dallas today, you would be flying into this jet all the way. Look how powerful these winds are. That's 135 knots. Here's 150. Here's 160. And here's 180. Almost up to 180 knots in some areas. This is a very powerful jet streak. Jet streaks cause turbulence. Why? Because there's a lot of divergence with them and a lot of convergence as well in some areas. So they're going to trigger a lot of lift around them. Notice all the divergence up here in the left front quadrant of a jet. There's also divergence on the right rear quadrant of a jet. Well, here's where the low is. Right in that right front quadrant of that jet. And that's why that low developed. It was been following along with that. Oh yeah, down here, for example, you have the segment, you have the turbulence. A lot of that turbulence is caused by that jet streak. The left front and the right rear quads of the jet have a lot of turbulence with them. And there's a lot of low-level wind here, probably causing some wind shear. The icing here, just looking at this front, notice the temperatures are in the 50s here, just behind the front, but they drop off into the low teens back here. So there's a lot of cold air coming in, but maybe the cold air aloft is cooling, but there is an area probably that hasn't completely cooled off yet where the icing is occurring. And many times behind a cold front, especially if there's a weak low riding along it or whatever, you get that icing. So you can see all the different impacts on your flight just based on looking at the circulations on this weather map and the 5 up at 300 millibars. So hope you got a little bit out of that, and let me know if you have any questions.